In this demo, I'll walk you through our multi-agent site reliability engineering assistant that accelerates incident investigation and even auto-heals production issues by synthesizing logs, metrics, Kubernetes events, and runbooks into one experience. Modern distributed systems are powerful, but they're also complex. When a production incident hits, like a payment or API service going down at 2 in the morning, the clock starts ticking. Today, SREs are forced to act like human detectives, jumping between logs in one tab, metrics in another, Kubernetes events in a third, and runbooks somewhere else. Manually stitching together clues from these silos is exhausting and, more importantly, it extends downtime and hurts the business. This is where our multi-agent site reliability engineering assistant changes the game. Unlike traditional monitoring tools that simply display raw data, this GenAI-powered solution acts as an intelligent synthesis engine. Under the hood, we use a multi-agent architecture. One agent specializes in Kubernetes applications. Another focuses on log analysis. A third monitors infrastructure health. And another understands your operational runbooks. These agents work together, sometimes sequentially, sometimes in parallel, to correlate information for you, so you can literally converse with your infrastructure in plain English, instead of writing ad hoc queries in the middle of a crisis. Let's look at a live example. Here we have an alert for an API service whose database endpoints are returning 503 service unavailable errors. Instead of opening 10 different tools, I simply describe the issue to the assistant in natural language. Once I submit the query, the multi-agent system starts working in the background. It doesn't just search for a keyword. First, the Kubernetes agent analyzes event streams, looking for connectivity issues, pod health, and resource constraints. In parallel, the logs agent examines patterns in database connection failures. At the same time, the metrics agent inspects performance trends and resource utilization. Together, they correlate these signals into a single investigation, so I don't have to manually piece them together. Within minutes, the assistant delivers a comprehensive investigation report. At the top, we see an executive summary with key insights and a clearly defined root cause. In this case, the database connection pool has reached its maximum connection limit, causing connection failures and surfacing as 503 errors on the API. The report also includes impact severity, so stakeholders can quickly understand how critical this incident is. Below that, the assistant pulls in the relevant runbook procedures to guide remediation, without forcing you to search through documentation manually. The report breaks down findings from each data source. From the Kubernetes agents, we see the state of pods, deployments, and any events that point to connectivity or resource issues. From the application logs, the assistant highlights patterns in database connection failures and error stacks that confirm the pool exhaustion. For metrics and performance, it analyzes current resource utilization and trend lines related to this incident. For each of these views, the assistant doesn't stop at describing what went wrong. It generates recommended actions, including immediate mitigation steps that can be applied in under an hour, short-term fixes that can be completed within a day, and longer-term solutions to prevent recurrence. It also suggests verification steps, so you know how to confirm that your fix actually resolved the issue. The assistant clearly documents which data sources and APIs were used to generate this investigation. For example, we can see calls to resource metrics, performance metrics, log analysis APIs, and Kubernetes event streams. This turns incident response from a time-intensive manual scramble into a collaborative, data-driven investigation that bridges the gap between raw observability data and actionable insights. Instead of hunting through dashboards, the SRE gets a coherent narrative of what happened, why it happened, and how to fix it. We've gone one step further and added an auto-heal capability. For this database connection issue, I can select the auto-heal option directly from the incident view. The assistant prepares a remediation plan, then opens terminals into the relevant Kubernetes pods and executes the prescribed commands, essentially turning the runbook into executable actions. Throughout the process, it follows the generated auto-healing steps, attempting to fix the database connectivity problem without requiring manual command line intervention from the SRE. Once the auto-healing process completes, the assistant updates the incident log with what it did and the outcome. If we refresh the alerts view, we can see that the database connection issue has been healed and the alert status has changed accordingly. This closes the loop from detection, to investigation, to remediation and verification, all within a single assistant experience. To summarize, this multi-agent SRE assistant helps you query your infrastructure and incidents in natural language, without writing complex queries under pressure. Correlate logs, metrics, Kubernetes events, and runbook knowledge into a single investigation report. Reduce context switching by bringing all of your observability data into one cohesive view. And, where it's safe and appropriate, move beyond detection into actionable remediation with guided or automated healing. This isn't just another monitoring dashboard. It's your infrastructure talking back with clear explanations and concrete next steps. Thank you for watching.